Hi, welcome back to Missing Chemistry. This is Titration pH lesson number 1. Okay, today we're going to use titration and we're going to use pH to verify our results. Alright, so let's look at the first one. If 54 milliliters of 0.1 molarity NaOH to neutralize 125 milliliters of HCl solution, what's the concentration of the HCl? Well, you know what? I could use this right here, but I'm going to use this because it's just a lot easier to use. It's just it's personal choice. So M1 V1 equals M2 V2. So we're going to set up our, what I call my players to keep track of things. M1 V1, M2 V2. And I think if you guys did this, this would really help you a whole lot. Alright, so our first volume is 54 milliliters. See how it keeps nice track of that. Our first molarity is 0.1. Okay. Our second volume is 125 liters, milliliters actually, and our molarity is what we're looking for, right? So we're going to isolate for M2. So M2 equals M1 V1 all over V2. So M2 equals 0.1 molarity times our volume 1, which is 54 milliliters, divided by our V2, which is 125 milliliters. Milliliters cancel out, and M2 is going to give us a concentration of 4.32 times 10 to the negative 2 molarity of HCl. Now, we can use pH to see if this answer makes sense. Alright, so what I'm going to do is I'm going to go pH equals negative log times our answer, which is 4.32 times 10 to the negative 2 m, right? So when we take our calculator and punch in our pH, we get a pH of 1.36. And guess what, guys? That is definitely an acid. And this is an acid, so this makes complete sense, right? Alright, let's look at our second problem. It takes 25 milliliters of 0.05 molarity HCl to neutralize 345 milliliters of NaOH solution. What is the concentration of that solution? Okay, again, we're going to use the titration equation and we're going to use pH to solve the problem. So M1 V1 equals M2 V2. So M1 V1 M2 V2. Alright? So let's set up our players. Alright, our first volume is 25 milliliters. Our first concentration 0.05 m. Our second volume was 354 milliliters, and we're looking for M2. So M2 equals M1 V1 all over V2. Now see how easy this is? By doing this right here, you're able to keep track of all your numbers. It just makes everything a lot easier than try to do it in your head. M2 equals 0.05 m times 25 milliliters, okay, divided by 354 milliliters. Alright, so that cancels that. My M2 value is going to be, of course, 3.62 times 10 to the negative, I think it's going to be 3. Let me double check on my calculator just to make sure. I think it's negative 3. It sure is. As a matter of fact, to make it more correct, I'm going to have to do a little bit better than that. I want to double check this, because this is important. But it looks like it's going to be what I thought it was. Yep, I've got it. It's going to be 3 point, I rounded it up, so I'm going to round it back down. 3.53 times 10 to the negative 3. Okay, now that I have that, I'm going to plug that in for my pH. pH equals a negative log of right, and so my pH is going to equal 2.44. Now, if you know anything about pH, you know that's an acid. And we are looking at sodium hydroxide solution. So there is an equation that can fix this. So you go pH plus POH equals 14. You could also do it another way, using the hydronium hydroxide ion concentration with kW. You could go this route, but that's a lot of work. So we just take our pH, which is 2.44, right? I believe that's our pH. Let's double check. Yes, let's double check that, because I think our pH is going to change a little bit because we changed a couple things here. So negative log of 3.53 exponential negative 3. Just want to make sure. No, it's about the same. So you take the pH, put POH in there, equals 14. So POH is going to equal 14 minus 2.44. And I'm going to get approximately 11.56. Now, that answer makes sense because this is a base, and NaOH is a base. So that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.